Assalamualaikum warahmatullahi ta'ala wabarakatuh dan selamat sejahtera. Bismillahirrahmanirrahim. So we start our class now. So today we need to understand how the frequency of the radiation affects the stopping voltage, stopping potential, or the stopping voltage, Vs. So I repeat. So how the frequency of the radiation affect the stopping voltage or the stopping potential. Okay, so before we continue, so I just to remind you what is meant by the intensity. So intensity of radiation is constant. That means number of photon per area is constant. Okay, so we look for the intensity for this diagram. So first diagram, second diagram, and then the third diagram. And then what we can see here, so the number of photon in the diagrams are constant, but the frequency of photon here, is the F1, here is the F1, here is the F1, here is the F1. And then for the diagram, second diagram, so frequency of photon is the F2, and then the diagram number 3, so the frequency of photon is F3. So the number of electron are constant, number of photon per area are constant. That means the intensity of constant, but the energy of photon for each of the diagram are different. Why? Because the frequency are different. So frequency for the photon in the diagram 1 is F1, and then the frequency of the photon in the diagram number 2 is F2, and then the frequency of the photon in diagram number 3 is F3. And then for each photon, then we can calculate E equal to HFI. And then for the diagram number 2, so the energy for each photon is HF2. And then for the diagram number 3, the energy of photon, each photon is E3 equals to the HF3. And then we have here F1 is lower than the F2, and then the F2 is lower than the F3. So according to the relationship E equals to the HF, so we can get the energy of each photon in the E1 here is referred to diagram number 1 is E1. So energy of photon for the diagram number 2, E2, and then in E3 is the energy for each photon. For diagram number 3 is E3. So in this case we have here is a E1 is less than E2, and then less in the compared to the E3. Okay. So if we change frequency of photon, so that means we change the energy of the photon. So according to this equation, if the frequency is increasing, so the energy of photon also increasing. Okay, so in this slide we know what is meant by the intensity, and then what is the energy of the photon. So we continue. Okay, so we continue. So take notes here. F1 is less than the F2, and then the F2 is less than the F3. Okay, so we go for the diagram, the number 1. They use the method A. Same with the diagram number 2, we still use the method A. And then for the diagram number 3, still use the metal A. So that means all the metal are same. So that means the work function is the same. Okay, so the photon E1 HF1 with the frequency F1, they hit the metal, and then electron is ejected, jump out from the surface. So then the electron has the kinetic energy, kinetic maximum energy. And then E2 HF2 energy of photon, they hit the metal surface. So we have the ejected electron with the kinetic maximum, so 2. So the photon E3 with the energy EHF3 hit the metal. So the ejected electron jump out. The electron jump out from the surface. So with the kinetic energy maximum 3. Okay. So all the metal have the same work function. Okay. Kinetic energy, kinetic maximum is equal to the, just to mention here, electrical potential energy, and then the kinetic maximum also can be calculated by QVS. Okay, just to mention here. So and then we have the K maximum 1, K maximum 2, K maximum 3. So we have the frequency is less. That means the energy of kinetic maximum also less compared to the kinetic energy maximum 2, and then compared to the kinetic energy maximum 3, because in this case F3 is bigger compared to the F2 compared to the F1. So the energy of photon E3 is bigger compared to the E2 compared to the E1. So that explains why the kinetic maximum 3 is bigger compared to the diagram number 2 compared to the diagram number 3. And then what can see here, the kinetic maximum here is equal to the QVS. So the QVS, so that means we can write the QVS3, QVS2, QVS1, and then we cancel for the QQ. So then we can see here the stomping voltage for the case for the diagram number 3 is bigger compared to the S diagram number 2, then compared to the diagram number 1. So we have here is the difference between the kinetic maximum, the stomping voltage. Okay, I continue. So if we have to plot the graph, so the graph here is the current, I is the current. So the unit of current is an ammeter. Here is the voltage, and then F1 is less than the F2, and then less than the F3. So because in this case, so we have the difference in the stopping voltage. See the difference in the stopping voltage. So VS1, VS2, and then VS3. So here is to the direction of the negative voltage. Okay. So I just explain this one first. So explain by using the photocell circuit. The photocell circuit in this case is a cathode is a positive potential. Why? Because cathode is connected to the positive power supply. Anode is the negative potential because it's connected to the negative potential. Okay. So I continue here. Cathode is connected to the positive terminal. Cathode is a positive potential. So anode is a negative potential. I'll explain it before. So number 2, potential divider is adjusted slowly, then ejected electron. So the ejected electrons are slowing down to anode. So we increase the potential divider. So that means we are increasing the potential difference between anode and cathode. So that means the electron is face the repulsive force. So that means the electron is slowing down, moving to the anode because they need to face the repulsive force. And then we continue increase the we adjust the potential divider, and then at last there is no more electron can reach the anode, so the current is become zero. Okay, so if frequency is higher, so the energy of photon also higher. So that means the kinetic maximum of emitted electron also higher. Then of course the stopping voltage also become higher. So that's what explain how the effect of frequency can affect the stopping voltage. Number 4, relationship, just the notes here, relationship kinetic maximum and the stopping voltage is related by this equation. K maximum is equal to half m mass of the electron v squared, velocity of the electron, and equals to the EVS. E is the charge of electron. Vs is a stopping voltage. Okay. So I continue. So we plot the graph for the stopping voltage Vs. Again the frequency. So frequency of radiation is directly proportional to the stopping voltage. Yeah. And then K maximum is directly proportional to the frequency of radiation photon. And then K maximum is not depends on the intensity of radiation. K maximum depends on what? K maximum depends on frequency of photon. Change frequency of photon, we are changing the energy of photon by, because F is the energy of photon can be calculated by this equation. Clear? So that's why we have the graph here. So I continue. So this one is the example. So in this case, I'm using the number or the magnitude. So energy of photon in this case is the 5.5 electron volts. So here energy of photon is 5.5 electron volts. So energy of photon here is here 5.5 electron volts. And okay. So that means in this case the energy is constant. Energy of photon is constant. So then what can see here is your we use the different material so as a cathode. So in this case we are using metal aluminium as a cathode. So the work function for the cathode is 4.3 electron volts for the aluminium. Then we change here is the silver. So the silver, the work function of silver is 4.5 electron volts. And then for the diagram number 3, so we are using the gold, metal gold, and then the work function is 5.1 electron volts. Different material, that means different work function. And then from the photoelectric equation, so energy of photon hit the cathode So and then they give the energy, sum of the energy to the material to do work, and then sum of the energy they give to the electron as a kinetic energy maximum. So 5.5 energy of photon, work of function plus the K maximum. 5.5 electron volt is energy of photon. Then 4.3 electron volt is the work function. That means we can get the kinetic maximum 1.2 electron volts. 1.2 electron volt. So and then is equal to the K maximum is equal to the QVS. Then we have the 1.2 electron volts. We finish the calculation. We have 1.2 volts. Then same with this diagram number 2. Work function 4.5 electron volt. The energy of photon is ni. We solve the problem here. And then we have the stopping voltage is 1.0 volts. Same with the diagram number 3. So we have the work function 5.1 electron volt, energy of photon 5.5 electron volt. So we have the cap maximum 0.4 electron volts. Then we calculate here. So we have the 0.4 volts, the stopping voltage. So for this, just to give you the conclusion here, what we can say here is you change the materials. That means we have the different work function. Aluminium is 4.3 electron volts. So the silver is 4.5 electron volts, and then the gold is 5.1 electron volts. So that means for the different work function, we have the different kinetic maximum energy of the electron. So we have the different here. So because we have the different in the kinetic energy maximum, then of course we apply this equation, we have the different answer for the stopping voltage. So case number 1, 1.2 volt. For this diagram, 1.10. For this diagram, the third diagram is 0.4. So that is explanation for these diagrams. For that, thank you very much.